All right. Hello, 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 and good morning, good afternoon, or good evening, wherever you might be. I appreciate you joining us this morning, or wherever you might be again, for the Studio Q live show. My name is Quinn Jacobson, and I'm going to kind of walk you through a couple of technical things today, or this morning, this afternoon, this evening. And we'll talk about Collodion and Collodion Recipes. And before I jump into that, I want to make sure everybody's in and then I can get my chat going here. Let's see. I just want to make sure I'm going to watch this chat on this side. There's a few second delay, but I'm going to check that out every few minutes or every couple, 3, 4, 5 minutes or whatever, and look for your questions because I'm going to go through some technical stuff here and I want you guys to be able to follow along. So welcome to the Studio Q live show. Again, my name is Quinn Jacobson. I've got this book called Chemical Pictures. That's kind of my whole thing, is making photographs through chemistry and primarily wet plate collodion. And we've got a couple of good things in here. And if you don't have this book, that's fine. I'm just going to refer to this because that's where my information is. And if you'd like to get this book, this is the limited edition. In fact, I just got one of my last shipments in of this. I have a few copies left. You can go to studioq.com. It comes with 40 plus high definition videos. Log in for that, and it's 230 pages. And again, it's got my Ghost Dance, my Beecher Island stuff, and my Sand Creek stuff. So if you're interested in that, and you're familiar with my work, or even if you're not, and you're interested in the technical, it covers both positives and negatives. So we're going to use that. We're going to be on, if you have that book, grab it. We're going to be on page 38 today for the most part. But if you don't have that book, don't worry about it. I'm going to fill you in here as well too. So good morning, Marcus. Good afternoon for you. You're a good early Guten Nacht almost, huh? So you're already on the wedding and ready to listen. Excellent. Excellent. So let's see who else we get in here. This week I had, I'm a couple minutes early actually too, but this week I've had a few inquiries, and that's kind of what I bumped this off of. People ask, how do you come up with the topics, or what do you choose to decide to talk about on these live shows? And it's mostly due to what my inbox or my direct message box fills up with. This last week happened to be about Collodion and Collodion Recipes, and trying to understand what it is that we're using. You know, that's one of our main components, right? Without Collodion, we can't make photographs. That and the silver bath are the big ones, right? Those are the two big ones. Most of the time, we don't have problems with Collodion, but it's really important to understand how it works. So that's what I want to do today, or in this live broadcast. I want to cover what is Collodion, how does it function, and some of the key components of what it actually does. And they're not really myths, but I'm going to kind of dispel some of the ideas around these recipes and why you'd pick one recipe over the other. So hopefully through science and through real data, I'll be able to explain to you what you're looking for, and the components in the Collodion, why you'd select one over the other. And there's only 3 things that we need to concern ourselves with, and then you can kind of leave everything else up in the air. And I'll give you my personal preference and why I choose to use what I use over a myriad of combinations you can use. So once we get in here, it's 10 a.m. in Mountain Standard Time in beautiful sunny Denver, Colorado, or the metro area of Denver. It's cool today, this morning, but it's sunny as always, usually. We have over 300 days of sun a year here, so it's really beautiful. So welcome, welcome, welcome. Again, my name is Quinn Jacobson, Studio Q live show, and we're starting to get some people in. Good morning, Pat. Good to see you. We're starting to get people in. So again, reiterating one more time, we're going to cover today Collodion recipes. What recipe should I use and why? Those are really kind of the mainstay, right? Kind of something not a whole lot of people talk about a lot, because for the most part, it's you either buy it pre-made, it doesn't give you many problems. The only thing is people look for certain qualities in it, and we're going to talk about those in just a minute. Hello, Peter O'Donnell. Good morning. Hello. Good afternoon. Good evening. So, as we gather people in here, this is going to go up on my YouTube channel after it's recorded. So, no problem if you're not live, but I like to do it live so people can ask questions as I go through this. So it doesn't sound like Charlie Brown's teacher, right? Wah, 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 wah. I don't know what you're talking about here. So let's go ahead and get started. I have some water and lemon and lime, some Wasser mit Gas, and some fruit in there. And I have a cup of coffee. So I'm all set. So occasionally I'm going to hit the water or hit the coffee depending on what I need. So let's do this, guys. Collodion recipes. Let's first talk about what collodion is. What is collodion? If you have my book, open that baby up to page 38. And if you don't, I'll read this. I'll give you some of this data. I'll put it up on the board. Chapter 4, page 38 is chapter 4 is listed alphabetically of every single compound in the process. The highlighted red areas are the dangerous stuff you need to pay particular attention to. But everything's listed alphabetically. So we're in the C section. So right after citric acid, in the CAS number, comes collodion. Collodion, the plain, non-flexible USP, United States Pharmacopoeia, and the CAS number. The chemical abstract number, the system that we use, we always use the CAS number to order chemistry, right? We never just give a name, because you can get in trouble if you just use the name, because sometimes the vendor, the person selling it doesn't understand what you're talking about, and especially if they don't know you're going to use it for photographic purposes. So the first thing, let's talk about, what do you mean plain non-flexible USP collodion? And the CAS number is 9004-70-0. That's the number you want to pay attention to when you're ordering it. Plain non-flexible USP collodion. Non-flexible, that's the key word here, the two words, hyphenated word. Non-flexible means that they do not add anything in it as a plasticizer or something to keep it flexible. You can buy flexible collodion that will not work for this process. It contains castor oil, and I've heard other things some manufacturers put in it, but that's the main thing. It will not work for photographic purposes. So you need the non-flexible plain USP collodion. With that, and if you get that use that CAS number, that's what you're going to get when you order it. So that's what I say in the beginning. Make sure you order this is sometimes referred to as low viscosity collodion or non-flexible. Now, in my book, it says between 4 and 8%. Realistically, you're going to talk to manufacturers, and this is a good thing. After we've gone through this circus a while ago, there's some collodion, plain USP non-flexible collodion, below 5%, 4% and lower, 3.5%, that will not work for pot prints, specifically collodion chloride prints. It will not work. I struggled with that for so long and discovered that you need to have 5% or higher, and you can't go too high, but at least 5% to make pot prints with this particular collodion. Good evening, Bernd and Peter. So yes, Bernd's one of the guys that asked to talk about collodion today, and along with Farid, I think, and Thomas. So 3 people inquired about this, so that's why I'm going to kind of ramble on about this collodion. But the 5% collodion is really important. There's enough nitrocellulose. We're going to talk about what's in it here in just a second. There's enough nitrocellulose in that to make the pot prints and to give the stability to the emulsion, if you will, and to make pot prints. 4% and less will not work. So it's really important. I say if you can, use 5% for everything. So let's look at what's in collodion. So there's 3 components in collodion. the general solvents and nitrocellulose, solvents and cotton. The two solvents in collodion are ether and alcohol. And let's look at the percentages on those. Ether is your main component. That's what when people say, oh, I don't want to add any additional ether. You've already got tons of ether in the collodion. It's mostly ether. The collodion is made up of mostly ether. That's why the smell is so strong. The next thing is you have alcohol. Alcohol, percentage-wise, and if you look there, 20 to 30% alcohol. 20 to 30% alcohol. And the last is nitrocellulose or cellulose. And that is, again, my book says 4 to 8. We can say 5 to 10%. But what you're looking for positives is 4%. And for pop prints, you're going to look at 5%. So if you're going to use this collodion for making pop prints, you want at least 5%. So those things that's what makes up collodion. So let's talk about what each component does, or why is it the way it is. So ether and alcohol is both a solvent. Majority of collodion is ether, and you know how fast ether dissipates, right? So when you pour a plate and you have that, you have the collodion, you pour the plate, you pour your puddle, and you go around your edges, your corners, and you rotate that, and you're letting that collodion drain back into your drain bottle. You pull it back up, nice, smooth, clean surface. That starts to skin over immediately. That means, and you can actually watch the ether come off and drop down. Ether's heavier than oxygen. It'll go right down to the ground. That dissipates quickly. So ether's primary function is to act as a solvent for viscosity or for flow even, right? So you have that, you bond to the plate, you adhere to the plate, you're able to flow it around, you adhere to the plate, and the ether is gone. Not all of it. Once you skin over, you still have some ether in there. What about alcohol? Well, alcohol has that 5% water in that. So that's going to keep that collodion wet for a little longer. That's why when people say, hey, I don't want to use ether to make my photographic collodion, I want to just use all alcohol. When you use all alcohol, you're adding a lot of water. Ethanol is 95% ethanol and 5% water to make the total 100% of say. So 5% water you have in there. So you're going to keep in high, dry desert climates like this, you can use additional alcohol. I would say if you cut all the ether out, you're going to have some other problems. Ether tends to help give strength to the nitrocellulose or how it's formed on the plate. So when you cut all the additional ether, we put quite a bit more ether in it to make the photographic emulsion. When you cut all that out and only use alcohol and substitute alcohol for the additional ether, you're going to have a lot of water in there. A lot of water in collodion will give you the crepey lines. A lot of times it'll make the nitrocellulose very, very weak. It's almost like wet toilet paper. So can you do that? Yes. Does it work? Yes. But you're going to have some problems, potential problems with the outcome of it. So just so you know, the solvents, the alcohol and ether, play critical roles. The ether for adherence, for flow, and then for ultimately giving some strength to the nitrocellulose. The alcohol acts in a similar fashion. It just hangs around a little longer because of the ethanol and the water. And then the nitrocellulose, the third component, the most important, is the cotton, right? So if you know about Schönben and how he came about discovering nitrocellulose in his little studio in the kitchen, he spilled nitric acid and sulfuric acid, took the apron, put it on there. The apron basically converted over into nitrocellulose, and he went to throw it away, and like flash paper. That's what nitrocellulose is. That's why it's the early. If you're any film photographers out there, you'll remember you look at the film and it says safety film 50/30 whatever. That safety film means that it's not made with nitrocellulose. That's what the original film. The George Eastman House, they have a whole program on conservation of these old films. Turn of century, 20th century, late 19th century, all those old films were made out of nitrocellulose. And if you've ever seen that movie Inglourious Bastards, spoiler alert here, at the end of the movie, she blows up the theater with film, nitrocellulose. So that's the third component in collodion. And that's why we talk about those three components, the role of the solvents and what the nitrocellulose actually does. So the nitrocellulose is the key to this. This is your actual substrate, or your emulsion, if you will, not substrate, but this is your actual emulsion. The alcohol and ether obviously goes away. So now the salts have something to bind with. So when you go into the silver bath, and we've talked about that, double decomposition and converting those over into halogens, that kind of thing. So, but let's talk about those salts now. That's the collodion, the plain USP collodion, non-flexible, right? Solvents and the nitrocellulose. Now, what do we do as photographers, or wet collodion photographers? We add more solvents to it for flow, for adherence, a little more time. This is just worked out to be thinning that material out. This is just worked out to be those two kind of ephemeral, if you will, solvents work very well for us to make a mixture that we can flow on the plate, hold our salts and give our salts to bind with, and then the silver bath to form those halogens in the end. So let's talk about bromides and iodides. This is where we get into the difference in making these different collodion recipes. Here's the first thing. You don't need both bromides and iodides if you don't want. The first recipe that Archer used only contained iodides. And I'm going to talk about that. He made a recipe. Primarily, everybody thinks Frederick Scott Archer made positives. He made negatives. That's photography, right? Making negatives and prints. So what he did, the very first recipe in The Chemist, 1851 in The Chemist, you can read his formula, and I've used it in his show where we put the stone on his grave and all that. I made a triptych of an old Heidelberg monastery, an old 10th century or 12th century monastery there in Heidelberg, something that Archer would probably photograph, and I made a negative of it. And I used his recipe, his first original recipe. It didn't have bromides in it, only iodides. That's going to play a key role when we talk about this here in just a second. So you don't need both salts. We use both salts in positives and negatives both today because over time we learned that adding a bromide gives some range in some of the colors and some of the middle ranges. It helps, but iodides are that's your main salt. So today we add bromides and iodides. Originally, or when Archer first released this process, it was only the iodides. And let's talk about what the salts do. The iodides, there's many different kinds of iodides, right? They're different: potassium, ammonium. So when I say iodides, I'm going to talk about Ki or NH4i. Ki or NH4i. Potassium iodide or ammonium iodide. NH4 ammonium iodide. So those are the two we're going to talk about today. What's the difference in those two? Here's the real key thing here. The difference in those two salts, or two iodides, is the potassium iodide, the Ki, is not soluble in solvents. In other words, when you make a batch of collodion for photographic use and you use Ki, you're going to have fallout or sediment or precipitate, and you're going to get a white layer of material at the bottom of your bottle or your mixture container, whatever. And that's because a lot of the potassium iodide is precipitated out of solution because it's not soluble in the solvents. And NH4i, or ammonium iodide, is soluble. So that's why you don't get any fallout, you don't get any precipitant, you don't have to clean your bottles. This thing about ripening and clearing, you can make a collodion and use it right away. You're going to have radically different qualities. Again, this is what we have to qualify when we say, does that work? Yeah, it works, but is it what you're looking for, right? So here's the thing. If you get, let me check this message board real quick, make sure we're good. Good, we're good. Here's the thing. when you make so the question is why would you choose Ki over NH4i or vice versa? Let's talk about what those salts do. The iodide is used for speed or contrast, ISO, ASA. So when we say speed, we talk about, how fast the film is, right? ISO 100, 200, 400, 3200. In collodion, what we're talking about are very, very slow ISO speeds to begin with anyway. A fresh collodion may be on the top end in ISO 3. I usually work with a collodion around an ISO 1 or so. So what's the difference between these? The Ki is not soluble in solvents. It hangs, and it's a slow process to turn to oxidize the nitrocellulose, or to change the color of the nitrocellulose to orange or red, or as we go down, and we'll talk about what that color means. So the lighter color your collodion is, the faster ISO it will be, and the tonal range will not be as extreme, or the contrast will not be extreme as a darker one. Bernd, hello. What happens to the collodion with less ammonium iodide? I'm afraid that was my problem, because the ammonium iodide is charged. Yes, okay. All right, that's great. There you go. There's probably your problem right there. He's asking, what happens if you don't put the 1.5 or the 3 grams, and you only get a gram in, or a gram and a half, and you're making for a 500 mil? If you're using my recipes again, this is based on what I'm talking about. What will that do? I think you can figure that out. That will not give you enough salt to oxidize the nitrocellulose, or to start turning. What happens? Let's say this. What color is iodine? Iodine is red, right? So as your collodion starts to turn, the redder it gets, the higher the iodine or iodide level it has. The higher iodide level it has, the more contrast and tonal range you have, and the more contrast you have, and the slower the ISO will be. Those are the trade-offs. So here's what I've done over the last couple of decades. I've decided that I modified a recipe. Quinn's Quick Clear, or Quinn's Collodion, is a modified recipe from an 1857 book, Waldeck's book. I modified that a little bit, and I found a balance for me, both in salts and solvents, that work, meaning that I get enough shelf life out of it. It stays good long enough to make positives with it, and yet still gives me that maximal tonal range that I want. My biggest problem with people, when you start using Ki, you tend to overexpose, and you don't get those tonal ranges in the images. Like I talk about constantly, most images positive, and this is what I'm talking about, most positive images I see today are overexposed and lack tonal range. You're just not exploiting that beautiful ability to what this process can give you. It could be chemically, and it could be exposure, or usually it's a combination of both. So you end up with not enough tonal range, flat, bright, overexposed, developing a lot of that silver, and you don't have any clear glass or black plate or whatever it is, and those graduations, those tones that you can get from black plate or clear glass all the way up to bright silver just aren't there. Yes, that's the reason why your collodion stayed white. That's exactly right, Barrett. Exactly. Yes. So here's the upside to that. You can add some more NH4i to it. Take a guess at what you're lacking, or what kind of charged and stuck to the beaker, or whatever, however you want to put that, and make a guess. Put a tiny bit of distilled water, dissolve that. Little ammonium iodide dissolves quickly in water. Distilled water, and then add that slowly back into your mixed collodion, and I guarantee you in a couple of days, or even in not even a couple of hours, your collodion should go from a straw yellow to like an orange color. I talked about this often, but I'm going to show you guys this again, because this is kind of my claim to. There's a couple of things that I will hold fast to giving to the collodion world, and this is one of them. My little chart about let me get to it here. My little chart, I should know the page number, but I don't. My little chart showing the color of, I got to take my marker out, the color of collodion as it ages, or is it, we say ripen, aging. Most people say ripening, and that's a good word. And when we talk about that, we start with a straw yellow color and we move progressively down to a red color. So here's my little, and for you guys that have my book, it's on page 53. Here's my little chart. So that talks about the pH and the content of silver in your silver bath and the color of your collodion. So as you look at this, you can see, and if you're watching this post live, you can pause that and see, slightly iodized collodion is on the bottom and highly iodized collodion is on the top. And they require different silver baths and usually a little bit different pH. Because what we're doing, this is the second part of it, right? What we're doing is we're asking those salts, those iodides and bromides, I use cadmium bromide and ammonium iodide. When we put those in the silver bath, we're asking those to convert and exchange that ion with the AgNO3 and turn to AgI, silver iodide, and AgBr, silver bromide. Those are two light-sensitive halogens that we're using in this process. So how does that work, and how does the color of what does the color of collodion mean? It means how much it takes on. It deals with pH, it deals with what kind of salt you're using, and it deals with how iodized the collodion is. That's why a lot of people have problems. They're going along making plates great, and they run out of collodion. They make a fresh batch of collodion using the same silver bath, and all of a sudden their plates are veiling. They have scum on them. They have unexposed silver, and they have to wipe it off with a cotton ball. That's a charged bath with a slightly iodized collodion, right? Or vice versa. It can happen either way, both ways. They're using an old collodion with a new silver bath. Both ways. So when you understand what the function of the collodion and the color of the collodion, that's why I've never understood people putting collodion in amber bottles. You need to see the color of your collodion so you know what you're dealing with speed-wise and tonal range-wise. You're very welcome, Bernd. I'm glad you joined in here. Delax TVV. How many months, years can collodion get till you want to make a new stuff? Yeah, great question. So that depends on what kind of images do you like to make. Do you want the ISO 2 or 3? And do you like the kind of the bright, the more flat images that you see out there a lot today? Or do you like the big, wide tonal contrast with really dark, higher contrast, and you'll sacrifice some of that speed and use a faster lens or better light or whatever? That's what will determine. When you use, here's the advantage of Ki, or using potassium iodide, the stuff that's not soluble in solvents. You get a much longer shelf life. Why do you get a much longer shelf life? Because it's not soluble in those solvents. So it takes a much longer time. You can speed it up with heat and light, right? But it takes a much longer time to oxidize that nitrocellulose or turn it, get that iodine flowing and turn it red or darker colors. So you have your collodion stays nice and usable for a long time. It just may, and when I say a long time, 6 months, a year, something like that. It just depends on what kind of image you want to make. Now check this out. You can go to a cadmium iodide, CDI, rather than a potassium or an ammonium. And that cadmium iodide, you will never, years and years and years, your collodion will never convert over. I mean, they say years. It's eternal collodion, so to speak, meaning that it'll never turn red. That's not what I want. I want that middle range. I want slightly high. I want the third bottle on the highly iodized chart, second or third bottle. If I'm making negatives, I want the second and the third bottle on the highly iodized. Why do I want that when I'm making negatives? Because I want contrast. And usually 99% of the time when I'm making negatives, I'm out in the natural sun, landscapes or whatever. Great example. Let me give you an example. There's an example of a highly iodized collodion and the pot print from it. I don't know if you can see that. Doesn't really do it justice, but that's all with very red collodion. That lasts, my NH4i Um, quick clear, meaning it's not really quick clear because it doesn't clear. What it means is it iodizes faster than the KI stuff. My stuff will go for 3 or 4 months. And then I'm down into a pretty red color that I can then use for negatives, or I can charge new stuff with it if I want to. And you can do that as well too. Months or years. Yeah. Bernd, can I just add some more ammonium iodide? Yes, you can. No, you can. That's what I'm saying. Yes, add more ammonium iodide. Take a guess of how much stuck in your beaker or how much you lost. If it's a half a gram, if it's a gram, whatever, dissolve that in a little bit of distilled water and then slowly add it to your white or your non-changing color collodion. Yeah, you don't need to make new. No, use that. That'll work fine. People, I know, and they should be a little bit paranoid of messing with these weights and amounts of salts in your collodion, because you can screw that up quite easily. Let me show you what I mean by red collodion. This was off my. This is some negative. Can you see how dark that is? It looks like iodine. That's very. You would not be able to. That's ISO 0.25 or less, a quarter of a 1.1 number 1, right? So it's very, very slow, very, very high contrast. But I could pour a plate and use it outdoors and make a negative with it. Be great. And I actually use this. This is a drain bottle off of big negatives. I actually use this to charge up fresh collodion if I want to speed up the process just a little bit, or if I want to make collodion for negatives, I'll add a little bit of that. You can do that. Yeah. Okay, Bernd. I think you're going to find that works for you. So let's talk about, just cover this again. Speed, or ISO, you're going to get better speeds in ISO with the KI, with the longer lasting potassium iodide, right? Because it doesn't turn as fast. And all we're talking about here, again, all we're talking about here is what color is it. That's all we're talking about. We're talking about this ISO here being 3, 2 or 3, and this ISO being less than 1. That's what we're talking about when we're talking about speed. Use your color. My current collodion is old Workhorse, and it's 7 months old, red color. My images are typically photographing buildings and make others look like. Yeah, that's great. Perfect. Wow, that's dark. How long is your exposures? Peter, outside there are 2 or 3 seconds for a negative. That's 4 seconds maybe on a day like this, 2 or 3 seconds. And that's with, I'm shooting probably f5.6, f8, something like that, outdoors doing a landscape. I'm very high in elevation here, so I have a lot of UV out here. But yes, that is dark, and that takes a lot of light. There's no way I could use that indoor with, well, I could use it indoor with artificial light if 2 or 3 minute exposure, something like that. But it's not as extreme as you'd think. Let's go to tonal quality. Here's where it becomes so subjective. So when I give you the science on this stuff, you say, oh, that's great. But when we talk about image quality, that's so difficult to define. It just depends on how you define quality, right? Like I said, do you like a lot of tonal range, or do you like the more bright, not so much tonal range? I mean, people tend to overexpose making positives in this process anyway, because they go, oh, this is slow. This is an ISO 100 film. I need to really punch it, give it a lot of light. So they tend to overexpose, number one. And if they're using a new or fresher collodion or a KI collodion, they get this really flat, kind of blown out image. It appears, it shows up, it's there, everybody can see it. And if you're in front of people that's never had anything to compare images to, they look fine, right? I mean, it's all relative. So I want to give that caveat that this is all relative. So when I say tonal range, when I say quality, that's so subjective that it's really difficult to define. I personally like images, like I said, with a lot of tonal range. I make a lot of negatives and I've made pretty much exclusively negatives for the last couple of years, to be honest with you. So I'm kind of in that mindset of I'm looking for contrast, I'm looking for clarity, I'm looking for clear glass and a lot of silver on a plate. So I'm looking for that wide range because I'm doing pop prints or printing out processes that require that. For positives, you don't need as much silver, you don't need as much time. They're very underexposed or thin negatives. So these collodion recipes, I can't believe how many are out there as I did a little bit of peeking around. They just really, they're not needed. I mean, you can pick your speed, what kind of tonal range, and now let's talk about shelf life. That's the last thing we'll talk about here, or not the last thing, but shelf life is the third thing in the list. Like I started, there's 3 items here. The shelf life, you will get more shelf life out of a collodion that uses, in addition to or solely, potassium iodide. Again, because it's not soluble in those solvents, it's going to take longer to break down, and especially if you keep it in a dark, cool place, it'll go for a long time. If you leave it out, have light hitting it, it's warm, all those things exacerbate the breakdown of this stuff. Same with NH4I, you'll really speed that up fast. So a longer shelf life with the KIs, and like I said, if you go to extreme stuff like CDI, cadmium iodide, you'll never change. Years and years and years, it'll never change over. But I don't think you get the quality images you could get with a properly ripened collodion. The second thing why I like to use, my personal preference is my recipe. You'll see it in my books. And I talk about KI in here. I give you recipes for that too. But my personal favorite is the NH4I recipe and the cadmium bromide recipe, right? Those 2 salts. Number 1, and most importantly, I get the tonal range. I get the tonal range. Number 2, I can convert that over to making negatives, using that as a negative collodion if and when it gets to the point where you wouldn't want to use it for positive. It gets too contrasty or too slow. And number 3, I don't have any of that sediment in the bottom of my bottles, and I don't have to use additional cleaning and additional hassle and all that stuff. So not that big a deal. There's great KI collodions out there, and if you want to use potassium iodide, absolutely do it. There's really good stuff. With the redder collodion for negatives, are you still redeveloping to increase density? Yes. A lot of times I am. Not always, and you surely don't have to. Here's what I find, Peter. I'll make, even with a really nice, ripe collodion, I'll make a beautiful negative. It'll look great. It would print wonderfully on most printing out processes, not all. But I'll just take what I call a 1 cup redevelopment with pyrogallic acid and iodine, and I'll just hit that, and it tends to crisp it up, cleans it up, crisps it up. Even if it doesn't need it necessarily, just a little 1 cupper will just really, really tie it in. And that, I like that. I like that a lot. Non-redeveloped negatives sometimes definitely can do that. There's no problem with that. But I just find when I just do a tiny little cup, a 20 mil or 30 mil cup of redev on even in a properly exposed negative density for density and contrast, if I just do that like a quick cleanup, I just tend to have better results. It may be just in my head, but that's what I do. So it's not really to add more density. It's to actually maybe just stack a little bit, just redefine that the silver that's there, the glass that's there. It just kind of cleans everything up nicely for me, and it really does. Visually, you can tell the difference, and the prints are wonderful. So those are the 3 things that you want to look for. I recommend that you add the additional ether to your photographic collodion and not substitute alcohol for it if you can. I recommend that you make your selection of iodides properly, depending on your speed, your tonal range, and your shelf life. And personally, I recommend that you go for it and you handle the most dangerous chemical in this process, the cadmium bromide. That heavy metal seems to be the most practical. That will give you some shelf life, additional time on your shelf life, I should say. I couldn't get that out. and it provides that mid-range. It just really, I believe it's the cleanest and best bromide for the process. So absolutely, Peter. Yes, no problem. So those, and then the speed, ISO or ASA, we know about that. The color of your collodion, and I'm just guessing at numbers. I don't know what the ISO is. I assume a freshly made collodion is around 3 ISO. I can use a traditional light meter, and I've been within, a fraction of a stop with fresh collodion on ISO 3 metering a scene. And that's not even accounting for UV and all that stuff, because the modern light meters do not calculate for UV, and that's primarily what this runs off of. But it's close, so that's why I say a fresh collodion is usually ISO 3-ish, and this thing is well below 1 ISO 1, and it just depends on your length of exposure, your quality of light, length of exposure, and how fast the lens you have. The additional iodide with water or alcohol. Water. Only water. And actually, if you're only adding a gram, Bernd, use about 2 mils of distilled or deionized water in a tiny beaker, and make sure it's all dissolved, and then add that slowly to your mixed collodion. And the water may put a little couple of swirls in there from the collodion, but just mix it up. It'll dissolve back in. And then let that bottle sit for an hour or two. And I bet you anything, you'll see the changes of color in your collodion. So store your collodion in clear glass bottles so you can see where you're at for your tonal range and your ISO and your shelf life. And then store them in a nice, dark, cool place. So heat and light on this will break that down further and further. As this gets, if I put it over there in the sun, this already looks like iodine. It'll go even further. So heat and light break that down faster. There's a lot of times people will make a KI. Absolutely, Bernd, you're very welcome. Bitteschön. You'll make a KI collodion, a potassium iodide collodion, and it'll be all foggy and it'll be a very, very light straw color, and they're waiting for it to clear, meaning they're waiting for that non-soluble Ki to fall out of solution. You can speed that up by putting it in a pan of warm water or putting it into some sunlight. That'll clear it really quick, and it'll start breaking that down a lot faster. Like I said, chemistry, organic chemistry, pH, and oxidation. Those are the two things in this process. You want to understand those very well. So if you get that, if you understand when you're oxidizing your iron in your developer, or how your acid works in pH, or the pH of your silver bath, how the uptake of silver and the double decomposition on the iodides and the AgNO3, you'll be ahead of the game for sure. Is 22, 25? Yes, that's 22 to 25 is quite warm. I would store my collodion in 20 degrees Celsius or 68 degrees Fahrenheit or cooler. But 22 to 25 is great. It's perfect. That'll speed your process up just a little bit. That would be considered warm in collodion. So collodion likes things cool. Collodion likes a cool environment. If you haven't noticed this, summertime is hell to make photographs in, because you're fighting that exacerbation of these processes. You go down to that molecular level, easy for me to say. You're fighting that with the heat. Heat exacerbates all that. So when you're developing, it's much faster. You might have to cut your developer. It's too strong. Your plate's sensitized differently. There's all kinds of things. So collodion, I talk about temperature with collodion. I like to store my stuff below 20 degrees Celsius if I can, 68 degrees Fahrenheit, 65, 68 is perfect in a dark place. And I like to work in 68, 70 degree Fahrenheit or 20 degree, 21, 22 degrees Celsius temperatures. Perfect. It's perfect. Perfect working conditions. And that's the ambient temperature of all your chemistry. So your silver bath, your collodion, your developer, kind of stored all at the same temperature. So, and fix even, so you don't have these radical shifts. Although fix you can get away with quite easily having a very different temperature that way. Ordering pre-mix. Hello, Jack Google. Ordering premixed collodion I received in amber bottles, so I should pour it in clear bottles to see it better. Any precautions I need to take in another bottle? Ether evaporation. So let's go back. Maybe I mix all my stuff, so I don't know what people making this stuff do, but I will guess. I'll go out on a limb. I don't know, but they mix it in amber bottles because what did I just tell you guys? Heat and light. Light will break that down too. UV will break that process down as well too. So stored in an amber bottle, what they're trying to do is I'm assuming, I'm not speaking for any manufacturers, but I'm assuming they're trying to prevent the breakdown of that collodion, that mixed collodion with the salts and solvents. And that makes sense. Yes, Jack, I would recommend that you go to clear bottles. Let me grab mine. Let me show you. I'm going to grab it right out of the cooler here. I'll show you my silver, or my collodion, rather, not my silver. Let me find a bottle here. Here we go. So I just mixed this the other day, and this is, of course, I have a drain bottle here, and I always keep a little bit of ether and alcohol in there so it doesn't gum up. And this is my favorite color, even a tiny bit darker as this ages on. I mixed this up last week, I guess. And it looks a little darker on my screen than it actually is. This is kind of an orange color. So this is how I keep my collodion. I have a couple of bottles like this in my traveling kit, and I use a drain bottle here, and I reconstitute this with the solvents, filter it if I have to, and put it back in there if I have bugs and stuff in it if I've been outside. So yes, I recommend that you put that in clear bottles. No need to worry about ether evaporation. Ether evaporation, if you read or watched any of my videos that I talk about that's more about pouring collodion, taking this collodion, pouring it on a whole plate, 8x10, some size plate, and watching that all that solvent come off, and then draining that excess into a bottle like this. There you have a very substantial difference of especially ether solvents. So your concentration of ether in this pour bottle is different than this drain bottle because of that, the area, the surface you just poured on there. You can actually watch the ether evaporate off of that. You don't want to pour that or drain that back into your pour bottle. Number one, you might have stuff in the air. You don't want to put that in your pour bottle. And more important, actually, number one, that different level of ether or solvent concentration, eventually this stuff will gum up and it won't flow very well. It'll be like pouring gum on a plate. It just gets thick. And then you run into other problems. Now you have sensitizing problems. Now you have silver uptake issues and all kinds of stuff. So I recommend, number one, seeing where your collodion is for your ISO, ASA, and shelf life and tonal range primarily. Number two, using a drain bottle so you can reconstitute that, put it back in your pour bottle. You have no waste and no loss, and you still have the flow and viscosity that you need or want. Does that make sense, guys? I have a few second delay on this chat, so I'm just going to wait and see if you guys have anything else there. Pat, you mentioned adding more solvents to your drain bottle and filtering as you pour it back. Yes, exactly. So, drain bottle is 250 mils. This is 125 mils. When I get this full of drained collodion from the pour bottle, I add 25 mils or 10%. This is a mixture of ether and alcohol. I add 10% back into this and then go back into my pour bottle. That reconstitutes both. And I'm leaning more, my new book actually says I'm leaning more, a little more heavy on the ether because that is the primary solvent that evaporates. But here in Colorado, where I'm up high and it's dry, alcohol gets there as well too. I don't mind a little additional water. If I overkill that just a little bit, it's okay. So 10, and I recommend leaning heavy toward the ether side because that's what you lose the most. Thank you for the information. Thank you, Jack. I appreciate you coming in. I really appreciate you guys. You guys are the reason I can do this. you support me, you buy my books, you buy my videos, you whatever you're doing to support me, putting a good word in for me here or there. I appreciate it. So I can do this kind of stuff because you guys make it possible. Barrett, do you talk about working an old collodion in your new book? It's coming next week. How to reactivate. Hey, oh good, yes. Oh good. I'm so glad your book's coming. That's awesome. You gave, yes, exactly. Yes, I gave exactly, and I do. I talk about it. Barrett's talking about this book, 230 pages. A lot of work, but I left a lot of gray area because it's all technical stuff. So yes, I talk about reconstituting your drain bottle, how to bring those solvent levels back up. Hello, Wet Plate B. How you doing? For long exposures, is it possible to add something like gelatin or glycerin to keep the plate wet longer? Yes, Mario. Yes, very good question. Awesome question. This is kind of crazy. I know you guys will think, wow, bing. I have a bottle of glycerin on my shelf over here. By the way, that's what I'm looking at when I talk about it. When I look over that way, that's what I'm looking for is my some of my chemicals. Yes, Mario. Here's what you do. Pour your plate, drain it, get the excess off, let it skin over, drop it in your silver bath, 2 or 3 minutes, whatever kind of image you're making. Pull it out, wipe the back off, and cover it with a 50-50, half glycerin, half distilled water mixture. When you make that plate, I'm sorry, back up. You can't, I'm getting ahead of myself. You can't do it on I tried that. I was just thinking about that experiment I tried. That did not work. What you can do after you develop the image in the field and you want to fix at home and you want to varnish at home, but you don't want to fix and wash and varnish at home or your studio, what you can do after you develop in the field, you rinse it off and pour a 50-50 solution of glycerin on the plate. Put it in your box, put it in whatever you're carrying your plates in, and it'll stay wet until you can get home or get back to your studio, fix it, wash it for the required time, and varnish it. I don't really have that problem because I take 20 liters, 30 liters of water with me. I wash everything and I use cyanide for the fix, so I wash everything in the field. But you can use glycerin to keep your plates wet longer. And not only add alcohol. The problem is you can't use glycerin with a silver bath. That's the problem with that. I think I'm understanding your question correct. Correct me if I'm wrong. Yeah, I think you're talking, I hope you're talking about post-production of the plate. You can't do it you'd have to go to dry collodion if you wanted to do that. Take your dry collodion plates out, make the exposures, come back, sensitize them or activate them again, develop them and fix them and wash them, that kind of thing. Oh, you'll love the book, Barrett. I'm so happy for you. Thank you for doing that. Cross Negs, how you doing? Hi, I just started the collodion game. Thanks for your information. Education, best from Germany. Oh, thank you. I appreciate that. I enjoyed my 5 years living in Deutschland. I appreciated that. I had a lot of fun. I taught all over Eastern and Western Europe and was fortunate enough to kind of reintroduce the process that had been gone for a long time for people that wanting to work in it. And it was kind of a rough start, and now I get people all the time. Europe's really exploded, probably in some regards more than America, actually. Really, before exposure. I'm sorry, Mario. There's really, because you have that silver nitrate in there. That's why it's called wet plate. You have to follow through with that. But post-production, you can do that. And I got ahead of myself because I already tried that. To be honest with you, I wasted some silver and I tried that and it did not work. Dry collodion, if you know how to do wet plate collodion, I have dry collodion in this new book. Try some dry collodion plates. You're not going to be doing portraits in your studio with it. It'll be primarily outdoor, bright light, but the dry collodion negatives are awesome. They work great. And you can take your plates out kind of like film and do all that stuff. But wet plate, unfortunately, no. And I've tried that. I've experimented with that. So thank you for clarifying. I don't want to misspeak here because that's the worst thing we can do when trying to give advice. I don't like safety advice or process or methodology advice that's wrong. And unfortunately, there's quite a bit out there. So forewarned is forearmed. Be sure you check out this stuff before you, especially safety-wise. Who was it that just wrote me? Sean just wrote me, and we talked about he's starting into the process, and he wrote me, and we talked a little bit about safety, and I told him, I said, be very careful about people talking about doing things in this process that you really are really super dangerous, and you need to avoid those things like the plague. Somebody's going to get hurt. You just be careful. I mean, safety is number one. Photographs are wonderful. It's great, but your safety, your health, you don't want to destroy you don't want cancer. You don't want to blow your house up. You don't want to kill your neighbors. You don't want to kill your neighbor's dog. You don't want to do any of that stuff. So safety number one and your health number one. Make sure you take good care of that. You're very welcome, Mario. 50-50 ratio, what exactly does that mean in Collodion? Is there more ether? You know what? This is what I'd say. I talk about, Bernd's talking about the reconstitution. This happens to be 50% ethanol, 95% ethanol, 5% water, and 50% diethyl ether. So I have this kind of working jug that I use, and I reconstitute my collodion, and I actually make raw collodion from this as well too, because it's a 50-50 mix. But what I talk about is I'm leaning more now toward replacing the ether. Say rather than 50% ether, you might want to add 70 or 80% ether and only 20% alcohol. If you do 50-50, it's fine. It's no problem. But if you live, and especially if you live in a high, dry desert area like I do, where you're at, you could do a 70-30 mixture, 70% ether and 30% ethanol. So if you had 100 mils that you wanted to reconstitute, you do 7 mils of ether and 3 mils of alcohol, and something like that. The old literature says QS. That's what the primary literature says. And what's QS? And it means quantity sufficient. So there's latitude there. So you can kind of experiment and see what works for you. You're not going to hurt anything. Like I said, ether evaporates away quickly. Alcohol, as long as you don't go too crazy on it. And like I said, people actually make collodion, don't even add any additional ether, and they add all that alcohol to it. So there's a lot of latitude there with the solvents, but you want to stay in, I say 50-50 on alcohol and ether if you're in a dry area, and 70-30 ether alcohol if you're in a more humid area, a more wet area. So I hope that in the collodion there is more ether. In the collodion, yes, the collodion there's more ether. Yes, the original plain USP collodion, absolutely. 65 to 75% is ether, absolutely, yes. So you're losing ether. Ether evaporates quickly. I mean, you can watch it come off your plate. It's evaporates quickly. That's why you smell it everywhere too. That's the primary ingredient in collodion, like I said, right there. 65 to 75% generally. You know, it varies. Each manufacturer is a little bit different. A lot of latitude in the solvents, guys. You don't have to kind of trip. I would be concerned more with the weight of the salts than the amount of, and this is by weight too, ether, alcohol, and nitrocellulose. That's by weight. The new one, yes. When you mix new collodion, the new mixture, this is brand new. I haven't used any of it. That has more ether in it than I would add back in. Because again, even on the surface area, you don't lose all of the ether going into your drain bottle. You don't lose all the ether. I'm just trying to guess. And over the years, I just came up with this 50-50. Seemed to work well, especially in the dry places. When I was in Germany, I think I used 50-50 too. But lately, as I looked through and kind of wrote this new book, I was thinking about it, and it was like it made more sense. It was a little more logical to add a little more ether, you know. My wife, there you go, Bernd. Yeah, he says my wife prefers the smell of varnish. I totally agree. And it's not the gum sandrach, but it's the lavender oil. Yes. And I know we've talked about varnishing here before, but varnishing is another one of those. In fact, I just had, maybe it was Ferret again. He that wrote, we had a conversation about melting images, right? And not kind of understanding, and this is how it relates, varnishing melting images. You've heard about that, or maybe you've experienced it. European people tend to experience this more than American people because they use a little higher percent alcohol, 96, 97% sometimes. And that's okay. But what happens is if you're using old nitrocellulose or red iodized, highly iodized collodion, and you're using a fresh varnish, sometimes those cell walls on that cotton they're just really vulnerable to that strong alcohol in the varnish, and it'll just melt your image away. So what's the solution to that? I say start with 10 drops of distilled water in your varnish and test your images with that same collodion until you don't melt your image away. It works real well. So there's a lot of problems in this process, but not a lot of them. As long as I can contextualize the problem, know what you've done and where you're at and what chemicals you've used, we can usually find a solution for your problem. Really important, going back to when I first started this video today, when you're ordering your chemistry, always use the CAS number. Always. Don't use the name, use the CAS number. Always, because you get the wrong stuff. And varnish on glass is not glossy in my case. Bad glass? No, not necessarily, Bernd, because you're not dealing with the glass, really. And the shadow areas you are, because it's clear glass, but you still have a layer of collodion over there. It's called drying dead. When you get kind of a matte finish, it's not glossy, means you don't have enough heat on your plate, meaning the water in your alcohol isn't evaporating out fast enough. And in the 19th century, they called it drying dead. It produces kind of a matte finish. Traditionally, you want your gum sandrach varnish to produce a highly shiny, glossy surface. One of the things that I talk about in the book is the old literature, the primary literature says blood warm. That would be 98, 99 degrees, right? That's not warm enough, I found. And especially in a humid area, because now you're dealing with relative humidity, makes it cooler, you've got water in the air. You want to take that temperature up. 98, 99 degrees is 30, 32, 33 degrees Celsius, 34 degrees Celsius. Take it up to 40, 45 degrees Celsius, 120 degrees Fahrenheit. Get it warm. Glass takes a long time to heat up, but it doesn't dissipate as fast. Metal, aluminum, heats up quickly, but dissipates very fast. And take the chill off your varnish too. And I recommend using test tubes. So you can get, number one, you can get the volume if you know what size plate you're making. You're only going to have to heat up as much varnish as you're going to use. It heats up quick. And I'm not saying get the varnish hot. Just take the chill off of it. And then the two combined, when you pour your varnish on your plate, run it around the plate, let it soak in. You run it off and you get it back over your heat source. You're going to start evaporating that water out of the alcohol off, and your varnish, your gum sandrach, your sap, and your lavender oil, which is the plasticizer, you'll have a beautiful, glossy, super nice finish. So more heat. No, it's fine. I don't mind. Q&A to ask all the questions you want. I don't mind. In fact, the varnish topic is great because we veered from the collodion. Old red collodion with fresh new varnish can melt your images. So it's a great segue there. But just make sure you get your plate really warm before you pour the varnish on. You'll have better results. Can you, in the summertime, if you don't live in a humid area, here in the high desert, sometimes I don't even heat a plate up and I can pour varnish on it on a hot day. Perfectly glossy, perfectly fine. So there's a lot of variables there. But in the cool, wet, you definitely want to heat that up. You want to keep that water. Gum sandrach and water They don't get along at all. And that drying matte or drying dead will really show up. And that's because a tiny bit of water still left in your varnish from the alcohol hasn't heated up and evaporated out before it dries down the glossy kind of surface. Yep, more heat. Well, what do we have? Do we have anything else happening? Let me look over here. Oh, nice. 21 people in. That's good. Ask me I'm open for Q&A. If you want to drift over to a different topic, if you want to talk about something chemical, technical, conceptual, whatever you want to do, I'll hang out for a few more minutes if you want. I have my battery charged here, plugged in. My laptop's plugged in, so I'm good to go. If you want to ask any questions, shoot away. I'll give you a couple of minutes here. Think about a question or something that's been on your mind, and we'll try to answer it. As I finish my coffee and my Wasser mit Gas. And mit fruit too. No questions? Well, I will say this. I think, oh, no, wait, we got Pat chiming in. Okay. Other than dust, what would you say is the leading cause of pinholes in the varnish? Great question, Pat. That's a good one. So what he's talking about is when you varnish a plate and you're in a really dusty area, or some people are using a hairdryer to do stuff, that really kicks up stuff you can't even see in the air. When you varnish a plate, those little tiny, it only takes a tiny, you can't even see it with your naked eye. It takes a little tiny piece of particulate matter on your plate. It'll cause a big kind of, a divot or a hole, like he's talking about, a mark. Let's call it a mark. So I like to have a very clean area. I'll spritz the air down. I live in a dry area, but I'll spritz the air down before I varnish a plate, especially the big ones. Make sure my varnish is nice and warm. The two things that will cause especially holes in the varnish are your humidity in the air. If you live in a humid place, what we call an orange peel surface. That's actually water in the air. The heat, once it starts cooling down, the water, while the varnish is still semi-wet, will get in there and cause a kind of an orange peel just from the humidity in the air. And the particulates, the matter, the dust in the air, definitely, like you said. Most of the time, people say, "Oh my God, I've filtered my varnish. I've cleaned it all out." There's a new bottle of varnish too that I just made. I've cleaned my varnish. It's super clean. I've filtered it and filtered it and filtered it, and I still get pits on my plate. And that's usually stuff in the air that they don't see or know. They're doing it, in their living room, and their cat's running around, or their dog, or their kids are playing, or dust is coming through the window, or whatever. It doesn't take much to pit up a plate. Varnish is, you have to have a pretty clean, septic, really clean area to work in. And then if you live in a dry area, like I said, I spritz the air down to try to pull some of that stuff out of there. And even if you live in a humid area, you can do that. Just make sure your plate's hot enough to deal with that. Temperature seems to affect shadow detail. Am I correct in saying this? I was outdoors shooting this week and found shadow details very difficult to capture. You mean temperature as in ambient temperature outside, Peter? What would affect shadow details would be the bromide in your collodion. That's kind of what that's responsible for, especially if you're dealing with greens, vegetation. That would be responsible for that range in there. And if they're positives, for sure. Temperature, what it can do is cause you to develop unexposed silver in the shadow areas, if that's what you're talking about. Rise in temperature, definitely. If you don't have enough restrainer in your developer, silver's covered the plate. So in your shadow areas, you can develop that unexposed silver really easy. I mean, it doesn't take much. It's there. You've got iron on it. You have to have enough restrainer to pull the highlights and the midtones down through and leave your shadows completely void, right? Completely clear glass or black aluminum or whatever you're doing. Mario says, thoughts on recipes with double iodide bromide. You know, I guess if you wanted to make the case for a double iodide, double bromide, a lot of these guys back in the 19th century thought it produced a better image. But I've played with them years ago. I fell into that whole thing of, you know, I tried every collodion recipe I could get my hands on in the 19th century, and all my stuff just didn't show. It was a waste of money for me, really. It really didn't show any results. I may have gotten a little longer shelf life. I could say maybe a little longer shelf life with them. As far as the image quality, I didn't see anything. So you can use them, but you're just using twice as much salt for really no reason. How can I get rid of the yellow stripes in the edge of the plate? You should, yeah. Those are Bernd's talking about the organic material. Probably your plate is laying on a plate holder that has material on it. That material gets in, you develop it out, you fix it. The collodion on the edges will build up and it'll be thick. Usually they're blue because if you fix in cyanide, they're even in sodium thiosulfate, they're ridges of collodion. How you get rid of that is you have a better technique of flowing the plate. In other words, don't leave a massive amount of collodion on the plate, and make sure you drain and also wick the plate off and try to tease that excess collodion off. You can't always do it. In the summertime, it's much better because the collodion is warm and it flows off of there a little bit better. But that's just the buildup of the collodion. Usually on the edge that you drain on, you'll have that buildup of collodion. But if you wick off just a little bit longer and pay a little more attention to that, you can kind of get rid of those edges. When photographing in the summer, does the heat inside the camera affect the collodion? I found that a few of my images in the summer are slightly foggy. Yes, okay, DelaxTTVV. I don't know your real name, but yes, it's your developer. Again, going back to Peter, Mr. O'Donnell's question. I think the shadow, what he's talking about, the shadow details and temperature, is actually the temperature, the ambient temperature, or not enough. Even the temperature can be cool and still have this happen. You need more restrainer in your developer. So what's happening is you've got your silver nitrate. You've sensitized your plate. You've converted those salts into light sensitive halogens, AGI, AGBR, and now you've got a photographic emulsion on your plate, right? But it's all covered with silver. Put it in your camera, expose the plate, your highlights, your midtones show up, your proper exposure, you bring it back out, and you pour that iron, acid, and alcohol and water on it. That iron is the reducer. It's going to reduce those iodides and bromides, specifically AGI, to the pure metallic state of silver. Midtones are going to grade down. It's going to do the same thing all the way down until you hit the shadow or the void areas. This is where you want your acid, your restrainer, to come in, say, give me enough time to develop all that and leave those alone, because it's all covered with silver. If you don't have enough restrainer, if it's too warm, et cetera, you can actually develop all that silver. So all your shadow areas are covered. If it's developer and not a light leak or a silver bath problem, you can take a cotton ball and wipe that unexposed developed silver off the plate, and there's your shadow. That's a real test to know if it's developer, restrainer issue, temperature issue, or if it's a light leak or a silver bath pH problem. I hope that makes sense. Sorry, outside temperature was cold. So I think what you're saying there, Mr. O'Donnell, Peter says it was cold. I was outdoors shooting this week and found shadow details very difficult to capture. So you're saying that everything was fine on the plate. You're just not seeing any shadow detail. Is that what you're saying? And if that's the case, it could be that your exposure needs to be a little longer, or you need to adjust your developer a little bit. All right, Daniel says, yes, for example, one shows the darker vegetation much foggier, whereas the other tones are much better. Yeah, okay, Daniel. That could be what kind of bromide are you using? If you're using cadmium bromide, that's kind of what that's responsible for. Those green vegetations, um, um, well, foggy. Does it wipe off? Daniel, does your what you're calling foggy? Does it wipe off with a cotton ball, or is it permanently on? Is it permanently fogged? A light leak or a silver bath problem will cause the permanent kind of fog. And what we call veiling is what we developer terms, when the shadow areas are covered or veiled, or veiling. We can take a cotton ball and wipe those off. That's from developer. Lack of restrainer, so you're developing that unexposed silver. I hope that makes sense. Yeah, some of these questions, I'd have to be there. What the light conditions, the temperature of the light, what time of day it was, your exact Collodion recipes and your developer, what kind of lens were you using? A modern lens, an uncoated Petzval lens, uncoated vintage lens. All those play in a factor. We're dealing with the visible light spectrum, chemistry, those kinds of things. Yeah. So Peter, if you do that, if you keep yes, that will help. You may not be getting that exposed. So your highlights come in first, 3, 4, 5 seconds, midtones 7, 8, 9 seconds, and then your shadow areas start to appear around 12, 13 seconds. So if you're not seeing those, you need to adjust your exposure or the temperature of your chemistry, which is a good point. More like veiling. Does it wipe off, Daniel? Does it wipe off with a cotton ball, or is it permanent? He says it's not oysters, more like veiling. Cadmium bromide I use. Yes, good. Beck Rapid Rectilinear 1890s. Okay. That's great. Yeah, those are pre-coating lens, so you're getting all the UV you need. Does your fogging wipe off? Does it wipe off with a cotton ball? I know there's a delay on this chat, so I'll wait. Permanent. Okay. What's the pH of your silver bath, Daniel? We'll wait for. I know there's a little delay here, so bear with me. He's saying his oyster kind of fogging stuff is veiling. Fogging is not like oysters. It's permanent. And I'm asking, what's the pH of your silver bath? That's what I'd look at, is the pH of your silver bath. If you're fogging in your void areas or your shadow areas, and it does not wipe off with a cotton ball, check the pH of your silver bath and check the specific gravity. See how much silver you have in there. Those are the two things you really want to pay attention to, especially the pH, because if your pH is off, if it's about 4, I would do this, Daniel. If you still have those issues, the next time you go out and you have that fogging in those areas, take 10 drops of nitric acid, and that's 10 drops if it's 70% nitric acid. Take 10 drops to 1 liter of silver nitrate and put 10 drops of nitric acid in your silver bath. And just start with that, and I bet you dollars to donuts, it clears that fogging or veiling up. That's that's usually a pH problem in your silver bath. And if you're using an inferior pH system, testing system, you need to really be specific on that, especially when you start running into fogging issues. You don't have it, and it's not a light leak, so you don't have as bad as some people have it. But you want to make sure that pH, if you're making positives, you can go down as low as 2.5, pH 2.5, pH 3 with positives, no problem. You don't need that much silver on the plate. Bernd, bitteschön, you're very welcome, and greetings from Denver to Heidelberg. I loved Heidelberg. I live 15 minutes from the Hauptstrasse there in Heidelberg. A great town. I loved it. Loved to go down and hang out. It was a fun town. So you enjoy your day. All right, guys, I'm going to call it good. I'll try to do this once a week. If you have issues or topics you want me to discuss in detail, if you want to look at the science behind them, if you want to look at my my personal take on how the process works, and I back that up with science. It's not just my opinion, but and if I don't know, I'll tell you, or if it's my opinion or my experience, I'll tell you that. But if you want to know specific things, send me an email, direct message, whatever. Which pH should it be around with? Oh, yes, older red collodion. I'd go down to pH 3. Go down to pH 3, definitely, Daniel. And I bet you anything that fogging will go away. Light leak in the camera for Daniel. Yes, Mario, that's a good point. But his highlights seem to be okay. It's just in the shadow areas. But that's my two things: light leak or silver bath pH problems with that permanent fogging. Not the stuff that wipes off. That's called veiling. That's a restrainer in a developer. If it wipes off, we know it's developer. If it's permanent, it's a light leak or fog or pH problem. But you're right, Mario. Such great information. Thanks, Pat. I appreciate that. Yes, and thank you for your patronage on all of that, your support, the good words you put out there for me. I get some nice email. I really appreciate that. Very welcome, Daniel. Toronto. Barbara in Toronto. She's a very well-known photographer there. I help her quite a bit. I have a lot of good Canadian friends up there, so I appreciate it. I got great friends all over the world. You guys are terrific, and I appreciate your time. Join me next week. We'll do it again. Send me your email. Send me your questions. Hey, Jack, thank you from Indiana. I appreciate that. Send me your questions, your emails, any topics you want to discuss. If you want to look at work, if you want to talk conceptual, if you want to stay technical, I'm good with all of it. I love it all. I love this process. It's so rewarding and so satisfying. And there's a great group of people involved in this, and I love to help you guys out if I can. And I try to reciprocate all the stuff you guys do for me. So you guys have a great day, evening, afternoon, wherever you're at. Thank you again, and we'll see you next time. See you from Denver, Colorado. Ciao.